No, I didn't want that. Let's go to this mode. There we go. Okay, so welcome everyone. Um, Back to our recurring thing. Now that we're going to go into the infinite universe. Um, anyway, so today I wanted to just go over a little bit more this assets on the Dion version of the Top Protocol, um, and what it actually means. And like specifically, I had mentioned yesterday going towards exploring the like asset ontology or the token ontology we are going to move forward with or we're still in the process of designing and moving forward with on our Tetra version of the protocol. So I just want to revisit a little bit what we did yesterday, just to quickly go over it. Then we're going to take a look at some diagrams, and my goal today will be to get everyone to understand a tweet that I put out this morning, or like to clarify and some understanding the tweet that I put out this morning around the fact that in with the right like tracking of data and all that sort of things, you can actually build like non-fungible token systems on top of fungible token systems, and vice versa. You can build fungible token systems on top of non-fungible systems, right? So there's this like relationship between the two, and it kind of all just goes hand in hand with how I ended the broadcast yesterday, talking about how fungibility is a subjective quality, and that by acknowledging that fungibility is a subjective quality, we can then define and understand what fungibility means in the context of on-chain behaviors, and then we can better control where fungibility should or should not play a role, or even how it should be considered on-chain. What is the conception in a distributed blockchain protocol for what fungibility can actually mean, or what it should do at all? So, all right. We're going to go back into our recursive nightmare for a second because I have to switch screens. So I'm going to do, I believe, this little guy. Boop. And then that. And then we go here. Okay. So here we go. We're back in our little code sandbox thing from yesterday. We're going to do the proof of concept Bramble.js Express app, which, by the way, if you're ever so inclined, just a little bit of plug here. Bramble.js, BRAMBLJS docs, DOCS topple.co brings you to this little nice handy, I don't know, set of documentation. But this is for the Dion compatible version of the JavaScript SDK for interacting with the Top protocol, and that's what this whole little thing is. And so even further, we can go and look at the, it's hosted on GitHub. It's all open source. It is also packaged and published on NPM. So feel free to go and play and give us some feedback. And we'd love to build the community and make the tools even easier to use and better to understand. Even though I know we're still in the midst of learning ourselves and trying to figure out what are the best ways and how to most easily communicate things, and how to make them easier, how to make them more user friendly. That should be just overall it's just a problem in the space at the moment, right? It's very difficult to get users to understand what is the value proposition of doing the things that we're doing. All right, so we don't really need this iPad thing there for a second. So what we do need, we're going to go here. We're going to make a new little window. We're going to put that window to the right. Not that far to the right, though. A little bit far to the right. We're going to come back here, paste that. So we have a nice little window there. We're going to change this and do that. Please ignore my set of, I promise you, I know it looks like I'm one of those, I just like keep all of my files on the desktop, and I do kind of keep all my files on the desktop, but only because I plan to delete them eventually. Don't judge me for that, please. It bothers me too, I promise. Ugh, we're not going to look at it. We're trying to ignore it. Why? Come on, man. Windows, stop being such a pain. There we go. All right. Let's hide the sensitive information again. So we're back. Recall, we had these little methods to do an address and do a balance and look up a balance at a particular address. And again, just a little bit of plug for some documentation if you're so inclined. Topple-r rpc.docs.tuple.co. And there's this postman documentation for the JSON RPC layer for how to interact with the protocol. And then if you go to tuple.services, you can sign up for a this is BaaS, blockchain as a service. So tuple.services is where you can go and sign up and get a free API key, just like in Fura, and go and access the chain. And let's see, the last thing I want to talk about. Okay, yeah. Then last thing, docs.tuple.co. We've been going all the subdomains. Let's just go to the first subdomain. So this is our developer portal. Again, please let us know if things are out of date, if things don't work, if, again, constantly in a state of trying to make sure everything is coordinated and well maintained. So lots of moving pieces, and support is definitely needed and encouraged. So with all that out of the way, and kind of some thoughts of, like I said, remember yesterday, these were just mainly the express calls, and all the actual, like, how you do the stuff is all here, right? So this is where all that documentation, so specifically look up like the Bramble.js documentation. It is doing this right here, right? So at you take in an instance of Bramble here. And here we're actually creating an instance of Bramble. So, I'm sorry, we pull in the class, and then here we're actually creating an instance of Bramble, and then here we create an instance of the services, right? And then it's these services that we use everywhere where we're doing, services.getBalance, and then services.getBalance, and services.generate asset code. And I know these are not asset things. I'm just sharing, how, if anyone is curious to how I'm doing all this, it's not black magic. It's just knowing the right commands to call, which in essence sometimes is basically all magic is. So anyway, so here we're just using that instance of the Bramble library, and these are all just inbuilt to the or there are things in Bramble available in the Bramble library. If I had not clicked away from them, we could go and see that. Okay, so like that create asset code, right? So Bramble, create asset code, and you can even see the line that it's at if you want to see how we implement it. Because this is all open source, because public permissions blockchain should be open source, and because you shouldn't really trust it if you can't ask your own questions. So then, again, like I said, I'm sorry, we're going back to this what we've covered previously, so the mint transfer. But this is all we're really doing, right? You just got to have this little params body. And this is what we should think of. This little params body is then packaged and sent to this Bramble transaction thing right here. And so we say, hey, Bramble, we have a transaction. We specifically want to create a raw asset transfer. Here we set minting to be true. So that essentially says this is going to be a minting raw asset transfer. And if we then go look here at under Bramble, it's transaction. Let's zoom in a little bit. Where was it? Transaction. Okay. So a Bramble transaction, which is let's just do that. There we go. Is going to go and it's going to make a request with the params that was sent. So basically, we use this method name. You're calling the method name. There's a method name called create raw asset transfer. That's what was happening over. I'm sorry, I know it's scrolled very fast. But over here on the left, we have a create raw asset transfer. That's just one of those methods that's outlined in the RPC. In fact, tuple create raw asset transfer. So you can go look at what the an example is an example response, and this would be an example request. So the raw, what's very important to note here, why I'm kind of spending this time, is that a raw asset, this is what I call a request, or what we call a request. Like this is a transaction request, right? Because what you get back is going to be a transaction, right? So this is, or in They used to I believe it's called a raw transaction in Ethereum terms. I don't know. The terminology may have changed, but here, I call this a raw transaction. Basically, it is the form of a transaction. This is what the JSON encoding of a transaction on the blockchain looks like. There might be slight differences, but if we go and we look, at the responses we were getting yesterday, they're not too dissimilar from this. So here we have the actual transaction itself. What's important to know about this being an unproven transaction or an unsigned transaction is that the signatures field is blank, right? So when the signatures value is blank, this is not a valid transaction. It could not be included in a block, right? Because there's no signature there. So users will instead take this message to sign. This is the serialized form of this. Yes, I acknowledge this is a trusted thing. You have to trust this. You have to recreate the serializers in a different language if you don't want to trust it. For now, we're going to trust Bifrost nodes. We're going to take this message to sign. The library, like Bramble.js, will then do something like this. If we use a key that it has to sign, and signing always takes in a message, right? So here it's a string. It's just going to take in this long string that we give it here, and it's going to generate a signature for us, which will then be like broadcast to the blockchain. So all of that like back and forth rigmarole that we just talked about is taken care of in these little lines, right? And really, it's actually taken care of in these lines, because what we do is we say send a request for a raw asset transfer. Then, once you get back the raw asset transfer, send that response to sign and broadcast. And sign and broadcast is, I believe, just above this. If I could scroll, sign and broadcast, and there we go. So we take the transaction that we got back from the RPC. We have to add a signature to it. That's an asynchronous process because sometimes generating signatures can be slow. Then you just go to request and you say, hey, go to the RPC and broadcast this transaction for me. And if it happens to fail, then just console log it and throw it so the next layer can catch it up, because JavaScript's awful about error propagation. Like I said, that was really just to kind of show you. Yesterday, I didn't get a bunch of time to kind of delve in and show you that it is all like there's not that many layers to what you need to do. Like, yes, it's an SDK. You have to understand like what you're doing, what the functions that you're calling in the SDK are. But then once you do that, there's really not much more. You just got to put in the right parameters and make sure that your addresses have funds. So there's no like contract there's no ERC20, there's no deploying or compiling the address or the contracts and all that sort of stuff. So that was what I want to share there. All right, so we can mint an asset and we can transfer assets. Basically, same thing, right? Not that much different. You just make some params. You call your transaction where this time it's a minting false, and the create raw asset transfer will do the same thing. It'll create the raw. It takes your request here. It creates a raw transfer. The raw transfer gets signed. The signed transfer then gets broadcast, and that's all happens in this little function. We're going to further specify this whole little thing I've been spending all this time on by looking at this. So this is what I mentioned earlier, this like transaction lifecycle, or like what we were just talking about, right? So that first thing that you send into a blockchain is what I think of as the transaction request. And then someone has to build some logics, has to go and turn that request into an unproven transaction or a raw transaction, right? And then a wallet usually will then take that unproven transaction and add a proof to it or a signature, and now it's a proven transaction. And now proven transactions can get broadcast to a network, and usually they go into mempools. And then following the mempool, so now once it's in a mempool, we might consider it a pending transaction. And block producers will then take pending transactions and put them into blocks. So once it's in a block, we can think of it as a proposed transaction. And then block verifiers will then go and verify all the transactions within a block in order to verify the entire block. And once it's been put onto a chain, once the block has been accepted by other nodes, we might consider that transaction confirmed. But until that block actually goes and is deeper in the chain and has gone through settlement, right, that's we shouldn't consider the transaction finalized, and finalization just happens. There are a couple different ways to do finalization, right? Ethereum is going with a signature aggregation scheme. Fundamentally, like BFT algorithms undergo, right? Everything is finalized. There is no concept of like confirmed, because the BFT algorithm itself, everything is finalized. And it achieves that through all the message passing. So this is specific to this whole little scheme. You could say is specific to probabilistic blockchain protocols. But the important thing, we don't need to go through consensus and all that stuff on the right side. The important thing for us to think about today is this little stuff right here. That there's this distinction between a request, so what I ask, what I say are the things to do, and the builder. And but the request may not be the same as a transaction, right? Because a builder has state. A builder has access to the ledger, right? Because it needs to. A request, you can see if we're able to form, if this can be a request, right? This is all stateless, right? I haven't said which UTXOs to use. I haven't said, like, I've given accounts. I've said which, let's see, sender. I have to specify who is sending, but I don't specify, and which is very similar to like in Ethereum, because Ethereum, you only have an account, right? And so by specifying the sender or an array of senders, you are able to specifically say, oh, use from that account. But in our system, we don't have accounts, right? We have UTXOs. So in order for someone to actually build the transaction, they take this sender and they look up the set of boxes. And that builder makes a distinction around what they're going to, like, which boxes are going to be used as the inputs to the transaction. And then, so that just means that the builder gets to make decisions that the user may not see. Or better yet to say, the builder makes decisions around the state to use, and depending on who owns the builder and which state the builder has access to, will determine how a request gets turned into a unproven transaction, or I guess for the sake of completeness, I should call this a request transaction instead of a transaction request. I just noticed that. Anyway, so that's okay. This is the point of the builder, and we kind of explored this a little bit yesterday, because I was explaining how in Bifrost we uncovered this really early on, because this idea of decoupling a node from the wallet, right, is really prevalent in Ethereum, because with account type models, it's a more stateless type way of being able to create your transactions, because every node has all the state. Whereas in Bitcoin-like models or UTXO models, it wasn't common, or like every node would have every state, but wallets would track the specific state for a specific account, right? Because then it would have to know the set of UTXOs that could be used to create transactions. Otherwise, you'd have to offload that question. You trust the other node to like give you back the set of state that you could use for the transaction. But in a fully trustless system, you don't want to do that. You want to control your own state. So you want to control your builder. But that's just the spectrum of trust models, of like different ways you can do it, and just identifying that there is logic and there's adversarial behavior that could come in from the person or the entity that controls the builder logic, or it could just act in a way that you don't expect, which is what we explored a bit yesterday. I think this builder, like, it's a little more common, or I think people understand a little bit easier who have been in the Web3 space for a bit, what this stage means, right? To add a proof, or in general, we talk about it as adding a signature. But we've adopted this nomenclature of unproven to proven, where a wallet holds a set of credentials, because in general, proofs of knowledge, of which digital signatures can be used as a way to implement a proof of knowledge. Proofs of knowledge are just one type of way to prove your ability to spend boxes in a transaction, right? Because that's what a proven transaction includes: a set of inputs that there is proof within the transaction that this transaction is allowed to spin the inputs, right? So hopefully, I know I'm trying to like show it with my cursor here, and if I could draw, well, that's what the iPad is for, but I didn't import this thing into the iPad. But anyway, so the whole point is there's a set of inputs in the transaction, and a proven transaction includes the proof for each input that this transaction is allowed to spend the inputs. Whereas an unproven transaction still has the inputs listed as well as the outputs. Both of them have the outputs. I'm just saying the inputs are the things you have to make a proof about. It has the inputs, but it doesn't have the proof yet. So it doesn't have the signatures. So you can't actually spend anything. So you have to add all the signatures, and you can also have partially proven transactions, right? So in the case of like multi-sig and that sort of thing, you can have transactions where you might have some proof on it, but additional proof is needed, right? So you can expand this out to support partially proved transactions as well. Okay, so this is the first part of the whole transaction lifecycle bit that we can kind of have in mind when we come back here, right? Because what we're doing is we're only making that request, and we haven't actually really looked at what it means for that request yet. So let's go back to the beginning. Okay, here we go. What do we want to do? Our container has been hibernated because we've been talking too much. Gonna refresh that browser. And let's see. We need another, man, I want to make another address. I don't want to do this with everyone because it's going to take forever. Man, it's so annoying. At some point I tried to be very, careful about keys and things, and was adamant that we had to make it difficult to deal with private keys. And then I started trying to use things, and I realized that making life difficult for using private keys makes my life difficult to preview things to people. So it's a constant struggle. All right, it seems like that's actually open now, so I don't know. Go back to this. Here we go. So we have this balance. We're going to do this whole thing. Do I have... No, I don't. I'm going to do this really quick. 1 second. I'm sorry. Here we go. Sorry, everyone. Oop. No, it was okay. I just wanted to get our set of notes from yesterday because that was useful for us to remember. I'm going to go back into this, and we're going to go back over here, and then we go. Okay. So if you recall, these were our little code sandbox helpers yesterday. Are we still the right place? 7.9 PQB SSE. Yep. Okay. Let's go ahead and mint another asset. This time, I'm going to not have any of this metadata or whatnot. I'm going to just mint 10 of them. And we're going to make this, today is not the 16th, today is the 17th, right? So we're going to make a new asset for today. We're going to make it A, sure. All right, so now, you guys could make this little app yourself. Actually, it's pretty easy. You see, this is like, I don't know, 100 lines, and the service logic itself is, another 100 lines or something. Honestly, the hardest part is getting a key file, right? Like, why is that the hardest part, James? Come on. Figure your stuff out. Anyway, so here we have a new asset transfer. I'm gonna try and rely on this a little bit more this time. I know there's got to be a key bind to do this. JSON Control-Alt-N. All right, we're going to try and use that from now on. Now, I just want to look at the structure of the transaction a little bit. We've been talking about transactions a lot. So this bit is just the JSON RPC stuff. So this is always going to be there. So we can see the JSON coding of this asset transfer is that we label it asset transfer, obviously. Here's a timestamp. Here are the signatures that got added because internal to this guy, when we call /mint, remember it goes out and the /mint will do a transaction, and that transaction will actually go and do this. Sorry, this can't go away, can it? Anyway, it does this sign and broadcast step right here. Right. So the response that we actually get returned was the response from this guy, because and then that's what this is right here. So this is the fully signed and broadcast thing. We could go along the steps and stop it if we wanted to and see each step along the way, but that's why we have the signatures in there. These are the new boxes that are going to be put into state, right? So we have looks like we got two boxes. So the first one is a polybox, because we require that a polybox is always around in a transaction. We require that. We require the destruction of a polybox. So you see how this ID right here, B5KN, is not the box to remove. Why is it not the box to remove? Is it because no, the ID should be that. Why is that not the box to remove? Well, that's embarrassing. That should have been the box to remove. At least I would think. BQ7W. What's that? I think this ID is not what I think this ID is for some reason. Anyway, that should have been the box to remove from the state, because it's going to destroy it. And man, that's really bugging me now that I don't know what that is. But here we go. So each of these two boxes, from these new boxes, right? These are the two new boxes, and these are the two where they're going to go. So these are saying who is going to then own them, right? So above these new boxes are just what the actual new boxes are that are going to be put in the state, and here we're actually taking those new boxes and saying, oh, well, these are going to be the new balances, or the new box values assigned to that thing, or to that account. So we see these are both going back to the same account, AAIS3, AAIS3, and we're creating a new polybox of value 4000. Same thing here. And if I had to bet, this is one of the things we actually improved in Tetra, is we make these transactions much easier to read. They're much more symmetric, because in dealing with this, it's a little frustrating what data you have and what data you don't have at times. So know that we acknowledge that. But the important bit here is that we have an asset, and I had promised yesterday that I want to make another one, but this time we're going to make one. Enter. There we go. We got another thing, but this time our quantity is 1. And if we go back and we look at this, oh, we actually spent some polys that time. Or somehow we spent some polys. I don't know. Let's see. So we got that. And we're going to go here, and we're going to do that, and we're going to Control-Alt-M. Oh, wait. Our 1 didn't get... Oh, it did. Okay. So here we go. We have our 1. We have our 10. Yeah, in retrospect. Why? It's bugging me. Anyway, here we go. So we have a total of 11 here. And let's see, just for the sake of fun, I'm going to do it one more time. I'm going to say a 5. All right, there we go. We're going to wait. We're going to refresh. There we go. Got 3,800 here. Control-Alt-M. The bottom. All right, so we have our 5, our 1, and our 10. Right? They all have the same asset code, ZLVX, which is different than our TuxQL from yesterday, TuxQL, and this is from an earlier one. All right, so now we have 3 of these, and what I'm going to do is recall what we did yesterday in our little thing. I know Being pedantic, but we're going to IAS3, aren't we? I don't want to go to IAS3, please. I would like to go to the mall. No, I'm joking. I would like to go here. Actually, yeah, there we go. Let's transfer to that one, but we're going to transfer this other asset code. Not this one. Dang it. I'm sorry, guys and gals. So we got that asset code. We're going to copy. We're going to come here. We're going to change that. Nope, that is not what I meant to do. There we go. Oop. All right. So let's see what happens if we try to move 20 when we only have 16. Dang it. All right. What happened there? This should error. Something went wrong. Thank goodness. All right. Could not validate transaction. Requirement failed. Insufficient funds available to create transaction. So the error where this came from, so just going back to our little diagram that we went over in the beginning, right? This error, it's a insufficient funds available to create transaction, right? So this was an error in the builder, right? This is why we got an error there. Whereas if let's try and maybe do something else. Let's see what other kind of errors we can cause over here, like giving everyone a heart attack because I'm trying to do stuff off the top of my head. So let's see. We had a 10, a 1, and a 5, right? Let's try to send 2. Let's try to send 2 to someone. Yeah, this should work, right? So we're doing a transfer transaction. So here is our transfer transaction that we just did. Control M. So we see, just again, transfer transaction. We can look at the new boxes. So we're going to make a polybox. We're going to make a new polybox of quantity 3600. Oh, that was why. Dummy. Because these from things are not the boxes to remove, are not the IDs for the boxes, the new boxes. Why was I so hung up on that? Anyway, I'm sorry. That was my mind. I'm glad I resolved that in my head. But anyway, we're going to make a new polybox. We're going to make a new asset box, and we're going to make another new asset box, right? And so this one's the one with our 2. That's what we asked for. But then what the heck? Like, why do we have an asset box of 14, right? Originally, our thing was not 14. We had a 5 and a 1 and a 10, right? Like, what's the deal? Why'd you do that, Bifrost? Like, why are you telling me that I have a 10 or I have a 14 and a 2? You combined you combine something, right? I don't actually know what I combined because my security roots are all 1s. And the metadata, I don't have any more metadata here. I at least have metadata here, right? And so the answer really is that is what I had mentioned yesterday, that the Bifrost is a fungible token system at the base layer, right? So we could introduce fungibility. I will have to not give everyone else a heart attack and try and do it live on stream. But we do have a method available, a parameter that you can include in here called a box selection algorithm, where you can specify the input boxes. So we could have specifically said, to fund my transaction of 2 boxes, builder, hey builder, don't go and grab all of my assets that share the same asset code, which is what the builder did for us. Instead, hey builder, I want you to use this specific ID for to fund the transaction. And if the builder can do it, right, if you're only asking to transfer a quantity less than 5, then the default builder in Bifrost will do that. It will give you back a transaction where it will, instead of like here where you have a 14 and a 2, it would have given you back a 3 and a 2, right? Because this 2 is the one we asked for. We said, hey, send 2 to somewhere. But what we didn't want the builder to do was to combine our other 2 assets necessarily. Maybe you did want that, right? But sometimes, like, you may not have necessarily wanted that. You expected it to use like the least value first, or the least box first, or something like that. So the reason that Bifrost does that is because Bifrost's goal as a application is dust reduction, right? We want to try to maintain the small set of UTXOs in state as possible. So let's see. Here's where we can go to a bit to the iPad, and I'm gonna go pull up another Excalibur drawing. So this is something we've been working on at Tuple for a while. We've been having conversations around it for a while now. But this this idea of how to control behavior, like on-chain asset behavior, right? So what we found here, I'm going to go to the iPad on the right there, if it opens up. All right, I haven't done this in a while, Mr. iPad. So, yep, all right. Cool. So what we just demonstrated was that, let's see. On chain, right? We have a token system or a set of boxes, right? That every box in here is uniquely identifiable, right? So A1 and A2 and A, 24, something like that. I don't know, right? And Z, I don't know, L and Y3 for the heck of it, right? So just what I mean by this is we have UTXOs with labeled boxes. Whereas off-chain, we might have, let's imagine just a, I apologize. Let's imagine we have some sort of data, like a NoSQL database. So we could have basically this exact same thing, right? Right. We could have records in a MongoDB collection that mirror one-to-one the boxes on chain, right? But importantly, while we might store like A1 inside the record that represents its off-chain like counterpart, we probably want to have your own like label for the off-chain database to reference it, and not like domain mix the off-chain and on-chain IDs for these things, right? So I'll have A1 in the document, but I'll also have 349. So document 349 or document 123 or document 942 or 108, and I'm literally just trying to make up numbers 721. So this one's, and just to make it even more complicated, we're going to say this one's A24, and this one's A2, and this one's Y3, and this one's ZL. Right? So now we have this mapping between the two. But on chain, right, what we just saw is that the assets, the data that's recorded on chain, so we're going to try and use like colors. Oh, no, that's an eraser, not a color. So let's just say this is a green asset. Or we're back to colored coins for Bitcoin. So A1 is a green asset, and we're going to consider A2 another green asset. But A3 is a whatever this color is asset, teal, I think, maybe. Forgive my inability to distinguish colors, please. And then we're going to say Y3 is a yellow asset, and ZL is another yellow asset, right? Well, the problem on chain that we just saw when you have a fungible system underneath is that because the chain considers these both as when everything's fungible, the chain is willing to combine A1 and A2, right? Even though you might not want it to. Right? So the way you can control it is say, oh, hey, I want to move A1, and I know chain that A2 is another of that type, but don't consider A2 in this transaction. Only use A1 as the input. Or I could either control that manually by the request, or if I actually know how to make the whole transaction myself, I can make the transaction. The problem there being that, remember, if I want to be able to construct this transaction myself, I also need to be able to know how to get the message to sign. Right, that's a very crucial part, because to do the next step in this transaction is to be able to generate the signature or to generate the proof. So it's not enough that a user might be able to define their inputs and outputs, like, and map them and do this thing that we're talking about on the right, where they can choose, even though the chain enforces fungibility, they can, enforce pseudo non-fungibility on the off-chain layer. That's what this process I'm describing is. It's like a way to enforce non-fungible behavior on a fungible system, on a technically fungible system. It's enabled because we're able to address state individually, right? A1, A2, which is, so the underlying system is a UTXO system, right? So we have a UTXO system, and then we build colored coins on top of the UTXO system, right? So now any green coin is fungible with any other green coin, or any blue coin is fungible with any other blue coin on top of that UTXO system, right? And then further to that, so I'm literally drawing with my hands, and when I draw with my hands, I realize I should make pictures. So we have the UTXO, we have the asset. That was a weird way to write a B. Asset behavior is almost like the B's you would write. This is a little fun fact for anyone. So I used to work as Batman at Six Flags. I know, very far afield from what we're actually talking about. This is the way we used to have to sign our signatures. So anyway, just a fun fact. The asset behavior, and then we have the, I don't know, let's just call it application behavior. How do you actually want the token to behave? Or like at the user, what's the user stories you're trying to build out of it? So here we would have like addressable, and or this would be NFTs is what I mean. So at the UTXOs, in my opinion, are NFTs, because they are, you can tell when a UTXO has been flipped. And even though the asset behavior is still fungible on the off-chain layer, we can enforce NFT-like protocols because we can rely on the addressable system of the NFTs of the UTXO system, right? So this is different than then you guess where I'm going with this, or maybe you can. So application behavior, asset behavior, DLT data model, maybe, because when you want to do an NFT here, and the asset behavior is fungible, what if this is fungible down here? Right? Well, then you have no hope, because there's no underlying non-fungibility that you can like build this NFT-ness on. And so you can have NFT-like behavior, but only at the application level. You cannot reflect that NFT behavior down, because there's no like underlying NFT behavior on which to build upon, right? And so you might recognize, in my opinion, that this is the account model, because account models are fundamentally fungible. Everything inside them is considered the same. You can address them individually, but you can't, like, everything within a single account is fungible, because it's just a number. So you can have this as an NFT, where this is a UTXO model. So because we have an underlying NFT like UTXO model, we always have the ability to like fall back to that NFT-like model. And this is why UTXO blockchains are better for traceability, and like in general for, I think, distributed trust systems, but definitely for systems where you need to be able to consider the full life cycle of something in a like passive, low overhead kind of way, because it's literally built into it. I'm not saying that you can't add additional data and additional context to underlying systems to like replicate them, but you can already see complexity always goes up as you build more on top of something. Complexity always increases, because you are recreating things. The more you build on a system, the more complexity there is. So complexity increases as you go up the stack. And so the more, like, the further you can bring functionality down, right, like to the lowest layer, just the better, or not better, but just the more like expressive systems you'll be able to have going up the stack. At least in a very like hand wavy generic way. I'm sure many arguments can be made, and if anyone wants to argue with me, I am my DMs are open, and you can find me on the top level email, and I'm more than happy to, like, have anyone on and have a panel and have a discussion. And I'd love to just have a conversation around these sorts of things, because I feel like the asset maturity, or the maturity of like asset conversations, is very, very non-existent at the moment in the space as a whole. And we're intelligent people, and I would like to have intelligent conversations about those things. So the back to the actual thing. So let's come on, what are you doing there? All right, so new page. This whole distinction, and I know we got about 10 minutes left, so I'm just gonna maybe show some quick little things. So this distinction around, like, how do you provide NFTs on, right? If I just said, I think the underlying NFT or UTXOs are already NFTs, right? And if you can build fungible systems on NFTs, why then do you even care that you've got everything? You have fungible tokens, you have NFTs. Why would you want anything more, right? And I would, my response to that, and we've talked about this a bit, is that most of the use cases that we've seen in the broader space have involved combinations and like different shades of doing fungibility and combining fungibility and non-fungibility. And we again already have experience with things like certain fields will just get, like, certain fields we just can't even have an opinion about fungibility or non-fungibility. We literally, like metadata and security root, we don't have any behaviors, right, associated with these properties. Whereas that's what fungibility and non-fungibility are. We closed out yesterday by me talking about how non-fungibility was a subjective, or fungibility was a subjective quality, and also that it was a property level quality, right? That every property gets to define fungibility or non-fungibility. And so here we essentially have 5 properties, or technically 4, because this is a discriminator for the JSON thing. So we have for the JSON decoder, I mean. So we technically have 4 properties here, right? We have security root, metadata, quantity, and asset code. So quantity, the field quantity, has to involve some sort of like metric around controlling the number of boxes, or the number of UTXOs that can be created from this asset, right? We can't go less than 1. So at most, this asset could be broken up into 14 different UTXOs, right? Or it could at most be represented as 1 UTXO, because all 14 of these elements could live in 1 UTXO. So quantity, and so same thing in like the zero sum. So you can't, like I said, at most 14 separate ones, at least 1. So this is where we say that quantity kind of has these properties of divisible and combinable. Right? So we can define specific things. So we could also say that quantity, we could, for the heck of it, if we want, say that this is we could denote fungibility on this property if we wanted to, right? We could say that the property of fungibility for on-chain behavior is governed by quantity, right? That would be a really silly thing to do, right? Because then you'd have something like every token worth 15 is interchangeable with every other token that's worth 15, right? And we know in the real world that's like people would just steal all your funds because, well, I guess that's not actually true, but I'm laughing because it's in my head, I'm kind of thinking through the absurdity of what it would look like to do such a system. But because of that, like that kind of like weirdness that comes to mind to me, is like why fungibility, again, going back to the example we had a second ago of like, we could have the documents use the NFT ID of the UTXO in the off-chain database, right? So go back to that picture we had just a second ago, right? So we could have this off-chain database, right? We don't have to put our own ID. I'm sorry, we don't have to put our own ID on it, like 399. We could technically, I guess, call this A1 and call this A1, right? But you're domain mixing, right? And if you've ever like, it's if you don't have a lot of experience programming, you'll have to just trust me. But I feel like this would be it kind of like gives me goosebumps to think about how trying to mix domains and like making things like entangled like that, right? It usually never results in very good code if you make things do more than what they're supposed to do. So when you overload things, that tends to give you hard to read and like hard to learn code because there become implicit relationships that aren't easy to suss out when you're learning the code. So instead of using quantity to control both combinability and divisibility, or whatever I call them over here, combinable and divisible, to control the combinable and divisible properties, we defined a new thing called asset code. And asset code is where we define the fungibility property. And like I said, currently in Dion, everything that has an asset code that matches is considered fungible. But these other two properties, metadata and security root, we don't even have an opinion on. Like literally, the protocol itself will just ignore it. If there is no value stamped on the output, if the off-chain application does not propagate the data onto the new assets, then it goes to a mono. It goes to its zero value or its like default value. And that is primarily because to define those behaviors for the asset for these like one's just a set of strings and one's a byte array, and how could you even start to think about what that behavior should be, right? These are really just data associated with the asset. But there are all sorts of other behaviors that you'd want to think about, right? In terms of the like, how do I control the maximum cap? How do I control, what if I want to have a series of assets that don't, I'm sorry, what if I want to have a series where there's only 100 elements of that series? Or what if I want to be able to give my tokens to people, but not have them use them for 10 days or something? Or when someone does get a new one, they mint it, they can't move it for 10 days or something like that, right? And maybe that'd be a terrible idea because then that feels like you could enable rug pulls really easily. But those sorts of handles, that logic, you need a hook, right? If you want to enforce those things on chain, you have to have some place to like hook that logic into. And so far, what we've come up with is something like this. So we provide two different levels of fungibility. So there would be three IDs, like I'm outlining here. There will be three IDs we associate to a box with an asset value. So there would be the box ID, that's just the UTXO ID. So the transaction that generates it. There's the asset class ID, right? So what is the like overarching class that manages, where's the policy? Really, that's so in other parlance, like what is the policy that manages this asset? So the class ID. And then what is the instance ID? So this particular asset box that I have will have a different instance ID. So, but then you have all these sorts of different things, right? So asset class ID is a shared value that will determine the behaviors of the token, because the asset class ID will be derived from a serialization of the policy and figuring out how to structure policies and what do we actually include in policies is part of our like ongoing design and like conversations. But things like talking about like what the ERC 721 standards are and what like I believe in Cardano like SIP 44 or SIP 25. Those sorts of ideas of what it like structuring the data in such a way as to be able to serialize it and then have community standards around the identification of certain types of classes or certain types of behavior. Certain types of behavior that are supported on chain. But once you define that behavior in the asset class ID, each asset instance ID you might want to define a whole class of assets, but then each individual asset, or they have a whole class of assets that have a shared set of policies but then you want fungibility internal to that set. So I might have I might make a non-fungible class ID, and then consider my instance ID things. Every element within that shares that class ID is interchangeable within it, right? Or I could have a fully I could have a fully unique NFT where I have a asset class ID and an asset instance ID that are just unique. There's only one box that could ever have that, and that's more along the lines of what is currently thought of as like a 721. But so yes, so the primary things, these asset properties, this was a bit of an old thing because it's going to be embedded in the class ID. The asset instance ID is how we primarily control the behaviors, because we are always going to retain that between, at least at the atomic level, between classes, there will be no interaction. But within a class, the instances, based on the types of behaviors dictated by the class ID, the instances may be interchangeable or unique or some blah, blah, blah. Quantity, again, just defines the ability to divide or combine different boxes. And then we're going to maintain security and metadata, as they are really useful for the connecting to traceability solutions. So yeah, this is my artistic rendering. And yeah, actually, I greatly apologize that I haven't actually been looking at the chat or anything. I know that's a terrible streamer move, isn't it? I'm gonna go to this move. Oh, okay, well, but yeah. So I guess I hope that was a little informative. I am happy to. We could honestly build out more of this NFT app if people are interested, or I'm happy with a few other topics we can go over in the series. There's other things we can talk about in terms of the other side of that, like life cycle transaction or the life cycle of transactions that we could go into as well. So lots more that we can. I'd be happy to share, and we can share in these. I'm sorry, I'm like trying to read into many things. So lots of more things that we can go over. Happy to share. I'd love to get further engagement and have conversations with people, explore different aspects. Maybe we do ones where we're like setting up nodes or that sort of stuff. So if you are interested, please feel free to find us on Twitter or Discord, or leave a comment on the YouTube stream or wherever you can. And we will love to, like I said, build a community and you can help us topple the world. All right, and I think with that, I know I've not been adhering to the script. I'm not actually sure where to find the script yet, so we're going to keep that between you and me. But thank you all, everyone, for bearing with me through this asset example, and I look forward to talking to everyone later. Have a good weekend.